Let's begin our journey by deploying a bunch of resources into Kubernetes by first deploying Postgres. So we have Postgres, Zipkin, and RabbitMQ, and these are dependencies for customer fraud and notification microservices. So with Postgres, what we're going to have is a service. This service is how other pods communicate with Postgres. So the reason for having a service is that the service takes care of load balancing if you have a bunch of other pods behind of your service. And if you want to learn more about this, check my course on Kubernetes where I teach how services work in detail. Then what we want to have is a volume in our node. Then we're going to have a volume claim. So this is how you can basically attach a volume from the host to the pod itself. Now for Postgres as well as Zipkin and RabbitMQ, we're going to use a stateful set instead of deployments. And a stateful set represents a set of pods with a single stable IP as well as storage. So this is the perfect use case for Postgres because we want to persist data, right? So all the roles, all the databases, all of that, we want to persist that data. Whereas with a deployment is a bit different and pods are ephemeral. If you want to learn more about deployments and stateful sets, again, my course on Kubernetes teaches you all of this. Now, just to let you know that you should never deploy Postgres on Kubernetes. I mean in production. But because we are testing things locally, then obviously we can. But if you are planning on deploying your applications to Kubernetes in production, then you should use a managed solution such as Amazon Relational Databases, i.e. RDS. And this is pretty much a managed database for you. And yeah, you should never run your databases inside of a Kubernetes cluster. RDS is one popular choice, but you've got others provided by GCP as well as Azure and other cloud providers. Let's go ahead and learn how to set up all of this.